Welcome to IIOCS.com Food Tech Club. Today's topic is modified and controlled atmosphere storage and also packaging. Let us first see about the packaging and storing in food industries. Packaging and storage are important issues for improving existence of the food item in the shelf. Storage is an important marketing function which involves holding and preserving goods from the time they are produced until they are needed for consumption. The storage of goods, therefore, from the time of production to the time of consumption ensures a continuous flow of goods in the market. Whereas when it comes to packaging material or the packaging system, packaging contributes to efficient distribution and it makes storage easy and can convey crucial handling information which will be printed on the packaging material. So let us see about storage and its role in preservation. The fresh quality products are the major requirements for the national as well as international food industry during this current era. After harvesting, especially for fresh fruits and vegetables, they continue their respiration process. To maintain quality, the respiration rate has to be reduced, especially when the products are stored for an extended period or shipped to distant markets. The best way to preserve quality and extend life is by cooling, and another method used to extend shelf life is the modification of the atmosphere surrounding the food product. Storage of foods in a modified gaseous atmosphere can maintain quality and extend product shelf life by slowing chemical and biochemical deteriorative reactions in the food and by slowing or preventing the growth of spoilage organisms on the food product. So that's why we have the modified atmospheric storage. The modified atmosphere packaging is defined as the packaging of a perishable product in an atmosphere which has been modified so that its composition is other than that of air. So you might have observed in the snack packets like Lay's, Kurkure, etc., other snacks foods. So in this you might see that the packet is filled with some modified air along with the chips, right? Often people think that they just add this air to increase the weight, right? It's not like that. It is the modified air which does not allow the growth of microorganisms, as well as it will not cause the oxidation of fats in the food product like chips and all. So that is the modified atmosphere packaging. The atmosphere of the food package has been modified. Next is controlled atmospheric storage. In controlled atmosphere, the concentration of oxygen, carbon dioxide, and nitrogen, as well as the temperature and humidity of a storage room are constantly regulated. So how is it different from the MAP, that is modified atmospheric packaging? So in controlled atmosphere storage or packaging, what do you do after doing the MAP, modifying the atmosphere? You constantly keep on controlling the modified gases. For example, if you have carbon dioxide, so the carbon dioxide concentration should be maintained the same till the storage or package time. So this is what the controlled atmosphere storage. So in modified atmosphere storage, you won't um, have any control on the amount of gases after some time of storage. Okay, but in controlled atmosphere, you will make sure that the atmosphere remains the same until the end of the use of the package. Controlled atmosphere storage involves maintaining a fixed concentration of gases or surrounding the product by careful monitoring and addition of gases. Whereas controlled atmospheric packaging is a method where oxygen, carbon dioxide and nitrogen are controlled and regulated inside the package itself. So if I give an example for CAS, that is controlled atmospheric storage, we can take the fruits and vegetable storage. Okay, the cold storage which is done for fruits and vegetables, so it will be first stored in a modified atmosphere. Okay, that modified atmosphere is then will be controlled with few sensors, like in ethylene sensors and oxygen sensors. Those sensors will sense the change in the concentration of gases, and there will be some controlling agents which will decrease or increase the required amount of gases. That is controlled atmospheric storage. Okay, that happens in one place. So in controlled atmosphere packaging, what is happening, you will have the controlling unit inside the package itself, like oxygen absorbers. If the oxygen concentration increases, the oxygen absorbers will absorb the oxygen in the packaging material, in the package. Okay, so that is after packaging, right? That's what it is, the difference between storage and packaging in controlled atmospheric system. Yeah. So let us see about the modification of the atmosphere. Atmosphere modification is usually used as a complementing for cooling. As I told you, in fruits and vegetable storage, what do? You keep it in cold storage and then do the atmosphere modification. The normal gaseous composition of air is nitrogen around 98%, then oxygen around 20%, and carbon dioxide around 0.04%, then variable concentration of water vapor and traces of noble gases. Food spoils rapidly in air due to moisture loss or gain, then reaction with oxygen, and the growth of aerobic microorganisms, that is bacteria and molds. Microbial growth causes changes in texture, color, flavor and nutritional value of the food, which can make food unpalatable and potentially unsafe for human consumption. Most products tend to keep longer in atmospheres that are high in carbon dioxide and low in oxygen. So let us see the history of this MAP and CAP. The first commercial application of the use of modified gas atmospheres were for the storage of fruits and vegetables. Then it came in 1930s for fresh carcass meat was exported from New Zealand and Australia under the controlled atmospheric storage in the early 1930s. Then in 1951, the Ogilvy and Ayers conducted studies on the effect of enriched carbon dioxide atmospheres on the shelf life of chicken portions. Then in 1970s, commercial retailing of fresh meat in MAP tray systems was introduced. Then in 1980s, European meat processing and packaging developed with centralized production of MAP meat in consumer packs for distribution to retail outlets. In the past few years, there has been a considerable increase in the range of food packed in modified atmospheres for retail sales. So let us first see about the modified atmosphere packaging. So we already know about what is modified atmosphere packaging, right? So let us see the gases involved in the MAP technology. The three main gases used in MAP are oxygen, carbon dioxide and nitrogen. The choice of gas depends upon the food product being packed. For example, so in foods like chips and all, we don't want higher concentration of oxygen. Sometimes it is completely eliminated also. But in case of fruits and vegetables, if you completely eliminate oxygen, then the fruits will not be able to respire. Also, in case of some food products where we want the anaerobic microorganisms to reduce the growth, so we can increase the concentration of oxygen. That time they won't be able to survive in the presence of aerobic bacteria. So used singly or in combination, these gases are commonly used to increase shelf life with optimal organoleptic properties of the food. Inert or noble gases such as argon are used commercially for products like coffee and snacks. However, the literature on their application and benefits is limited. Experimental use of carbon monoxide and sulfur dioxide has also been reported in literatures. So let us look at the gases individually. The role of carbon dioxide. Carbon dioxide is a colorless gas with a slight pungent odor at very high concentrations. It is suffocating and slightly corrosive in the presence of moisture. Carbon dioxide dissolves readily in water to produce carbonic acid that increases the acidity of the solution and reduces the pH. It is also soluble in lipids and some other organic compounds. The solubility of carbon dioxide increases with decreasing temperature. Therefore, the antimicrobial activity of carbon dioxide is markedly greater at refrigeration temperature. It has significant implications for MAP of foods. The high solubility of carbon dioxide can result in pack collapse due to the reduction of headspace volume. So, as we understood that carbon dioxide can reduce the pH of food, so that is on one side it is advantageous because many microorganisms which cannot tolerate the pH can be eliminated, but on the other side it is making the food acidic if it is solubilized in the food. So appropriate amount of carbon dioxide and the relative condition should be created before using the carbon dioxide gas. So next is oxygen. Oxygen is also a colorless, odorless and highly reactive gas which supports combustion. Oxygen has a low solubility in water. Oxygen promotes several types of deteriorative reactions in foods, including fat oxidation, browning reaction, and pigment oxidation. Most of the common spoilage bacteria and fungi require oxygen for growth. Therefore, to increase the shelf life of foods, the pack atmosphere should consider a low concentration of residue oxygen. The next gas is nitrogen. Nitrogen is an inert gas with no odor, taste, or color. Nitrogen has a lower density than air. It is non-flammable and has a low solubility in water and other food constituents too. Nitrogen does not support the growth of aerobic microbes and therefore inhibits the growth of aerobic spoilage but does not prevent the growth of anaerobic bacteria. The low solubility of nitrogen in foods can be used to prevent pack collapse by including sufficient nitrogen in the gas mix to balance the volume decrease due to carbon dioxide going into solution. Therefore, we studied in the previous slide that carbon dioxide can get into the food, it can solubilize in the food, right? So what happens if carbon dioxide gets into the food? So you will have less amount of gas in the package. So the package will shrink. That is, the headspace will decrease. So whereas if you use nitrogen is low soluble. It has low solubility in foods. Okay, that's why usually more of nitrogen gas is used in any kind of packaging when compared to carbon dioxide. Okay, let us see the effects of the gaseous environment on the activity of microorganisms. Food may contain a wide range of microorganisms including bacteria, their spores, yeast, mold, protozoa and viruses. The major concern is to prevent the growth of bacteria, yeast and molds in foods. Some microorganisms may survive during the shelf life period and cause food poisoning or disease in consumer. So let us see the effect of carbon dioxide on the microorganisms in the food. There are several theories regarding the actual mechanism of carbon dioxide action. So some of them are: carbon dioxide increases the lag phase and generation time of microorganisms, and these effects are enhanced at lower temperatures. So if you know about the various phases of microbial growth, the initial stage is the lag phase. Lag phase is the period where microorganisms will have very minimal growth. Okay, so at lag phase usually microorganisms will be trying to consume the required nutrients from the food. Okay, at that time the carbon dioxide, if it is present, it will decrease the speed of the growth of microorganisms. That's how the lag phase will be increased. So the next theory is carbon dioxide can lower the pH, as we saw before, and it inhibits one of the important enzyme, that is succinic oxidase, at carbon dioxide concentrations greater than 10%. Then inhibits certain decarboxylation enzymes and disrupts the cell membrane of the microorganisms. Let us see the effect of oxygen and nitrogen. So you know the effect of oxygen. So at lower concentration you will be able to inhibit the growth of aerobic microorganisms, also oxidative degradation of food. When it comes to nitrogen, it's an inert gas, as we saw before. It is used to displace air and in particular oxygen from the map. MAP technology. Since air and consequently oxygen have been removed, growth of aerobic spoilage organisms is inhibited. Nitrogen is also used to balance gas pressure inside packs so as to prevent the collapse of packs containing high moisture and fat containing foods like meat. Because of the solubility of carbon dioxide in water and fat, these foods tend to absorb carbon dioxide from the pack atmosphere. That's why it is better to go for nitrogen more than carbon dioxide. Okay, let us see the biochemical and physiological basis of modified atmosphere. The rate of respiration and metabolism doubles for every 10 degrees Celsius rise in temperature. Respiration can be therefore reduced by decreasing the temperature, oxygen level, and or increasing the carbon dioxide level in the storage atmosphere. So we have to control the rate of respiration and metabolism in case of fruits and vegetables storage, right? So how do we control the respiration? We control the temperature, oxygen level, and carbon dioxide. So we keep the fruits and vegetables in lower temperature. Both oxygen and carbon dioxide levels exert independent effects on respiration of the fruits and vegetables. When oxygen concentration is reduced below 10%, respiration rate is decreased. However, when oxygen concentration falls below 2%, this is important, anaerobic respiration may set in, thereby leading to the accumulation of ethanol and acetaldehyde, which we don't want. Therefore, oxygen concentration should be between 2% to 10%. The desirable effect of modified atmosphere on plant tissue is also attributed to lower pH due to dissolution of carbon dioxide in tissues. Ethylene, the growth hormone in fruits and vegetables, ethylene action and biosynthesis are also affected besides water loss and chilling injury. Next is environmental factors affecting modified atmosphere storage. First one is temperature and relative humidity. Ambient temperatures of the surrounding atmosphere affect the commodity temperature. Temperature changes also affect the permeability of the film, which increases with the increase in temperature. For example, in higher temperatures, the voids or the air spaces or the thickness of and permeability of the packaging films might be more. Okay, the permeability increases with the temperature. Carbon dioxide permeability responds more than oxygen permeability. Relative humidity has little effect on permeability of most film packages. Most common films are good barriers to moisture and vapor because they maintain high internal humidity even in dry ambient conditions. The second environmental factor is light. Green vegetables consume large amount of carbon dioxide and reduce oxygen through photosynthesis and would antagonize the process of respiration, which aids in maintenance of specified MA, that is modified atmosphere, within the package. Greening of potatoes can cause loss in quality unless light is excluded. Hence, opaque packages should be used for such commodities. Next factor is sanitation factors. The high humidity maintained within modified atmosphere packages may enhance the growth of plant pathogens. So, care must be taken to ensure proper sanitation and to avoid conditions favorable to growth and reproduction of such microorganisms. Fungicidal treatment of packaged vegetables is thus very important. Next is about controlled atmosphere packaging. There are two major classes of commodity which can be stored in controlled atmosphere. First one is dry commodities like grains, legumes and oilseeds. Then comes the fresh fruits and vegetables. So in dried commodities, these are the commodities. In these commodities, the primary aim of the atmosphere is usually to control insects and pests. So anyhow, we have very less moisture in this, but the main aim is to control insects and pests. Most insects cannot exist indefinitely without oxygen or in conditions of raised carbon dioxide levels. Controlled atmosphere treatments of grains can be fairly slow process, taking up to several weeks at lower temperature, that is around 15 degrees Celsius. When it comes to fresh fruits and vegetables, this allows prolonged storage with only a slow loss of quality. So let us see about these individual commodities. So first is about the cereals and oilseeds. In controlled atmosphere storage, an environment that is lethal to stored grain pests is created by changing the proportions of carbon dioxide, oxygen and nitrogen in the atmosphere surrounding the bulk grain in storage structures. Controlled atmosphere storage is different from an airtight storage where gas ratios change naturally just like in modified atmosphere, although both are carried out in more or less gas-tight storage structures. As the effectiveness of airtight storage is largely dependent upon the buildup of an infestation in the grain, it is not considered a satisfactory method. Controlled atmospheres are attained by introducing carbon dioxide or nitrogen from external sources, possibly prior to the buildup of infestation, thereby preventing damage to the storage grain. So let us see the advantages of controlled atmosphere storage. The main advantage of CA to disinfect grain is its potential to replace pesticides used in the grain industry. So you don't have to use pesticides after you harvest. The CA treated grain does not have any chemical residues which can cause considerable health concerns. In addition to providing an effective control of pests, the controlled atmosphere storage prevents mold growth, preserves grain quality and maintains a high level of germination in the stored grain. So these are the advantages. When it comes to limitations, the major limitation appears to be the high initial cost of airtight storage structures and the cost of sealing existing structures to the desired air tightness. So as I told before, controlled atmospheric storage also uses the airtight storage. There is also the cost of the generation and transportation of the gas. The interaction of controlled atmosphere gases with the storage structure can cause some practical problems. The introduction of carbon dioxide or nitrogen into airtight structures has the potential to increase the internal pressure on bin walls, and steps need to be taken to permit pressure equilibration. The only chemical reaction observed with Ca involves carbon dioxide in concrete silos, which are used as the storage bins. Carbon dioxide is bound by concrete through carbonation, which can result in reduced pressures developing in sealed new concrete bins. Also, carbonation of concrete can gradually extend to a depth where reinforcing steel is exposed, and the steel may eventually corrode and weaken the storage structure. Okay, so that's all about controlled atmosphere for grains. Now it is for fruits and vegetables. So the basic principle behind this is to reduce the rate of respiration, to reduce microbial growth, and to retard enzymatic spoilage by changing the gaseous environment surrounding the food product. This is achieved by reducing the concentration of oxygen which is required in respiration, or by adding an inhibitory gas such as carbon dioxide or carbon monoxide. The balance between oxygen and carbon dioxide is critical, and an optimal ratio is required for each specific product. So if we see the advantages, we have two main advantages. First is the fruits and vegetables stored under optimal Ca. Their practical quality advantages we'll see. Okay, then the market advantage we can see. First is the quality advantages. The first advantage is reduction in chlorophyll breakdown with resulting higher color stability. Then reduction in enzymatic browning in cut produce whenever low levels of oxygen are used. Then improvement in texture caused by the action of carbon dioxide on enzymes acting on cellular membranes. Then comes the reduction in some physiological disorders induced by C2H4, such as scald of apples and pears, and chilling injury of citrus fruits, avocado, then chili pepper and okra. Then the last advantage is reduction in microbial activity, especially moths. So that's about the quality advantages. Next is about the marketing and distribution advantages. Reduction in fresh food spoilage and quality loss through the distribution at the retail level. So this will retain the maximum yield which has been transported. Expanded radiation of distribution systems and market area. So you can, by this method of storage, you can take the food materials to longer distance. Then improved branding options and product differentiation. Obviously, when quality is increased, the branding options is also increased. The last one is potential for increased profitability in all fresh or chilled food operations. When it comes to limitations, development of off flavors due to accumulation of ethanol, acetaldehyde and other volatiles we can observe. Then increased softening in products such as cucumber, cauliflower, celery and onion. Development of physiological disorders such as brown stain on lettuce, internal browning and surface pitting of some fruits. Increased susceptibility of some products like celeriac, carrot pepper, Chinese cabbage, and citrus fruits to post-harvest pathogens. In the absence of competing aerobic organisms, anaerobic non-proteolytic toxin producers such as Clostridium botulinum are likely to have optimum growth conditions. So this is also not favorable. Okay, let us see the essential features for controlled atmospheric storage. First one is it should have mechanical refrigeration to maintain temperature of -1 to the 3 degrees Celsius. Next, the CA storage room is constructed gas tight. Okay, that is nothing but airtight. Reduction on oxygen nitrogen gas is induced into the storage by cylinder to reduce the oxygen level after room is filled and sealed. Carbon dioxide is added into storage from carbon dioxide gas cylinder. Excess carbon dioxide is removed by dry hydrated lime or ethanolamine, aluminium calcium silicate, activated carbon, magnesium oxide, activated carbon that mentioned before, or other carbon dioxide scrubbers. So if carbon dioxide production is increased due to the breathing of fruits and vegetables, we have to remove it, right? For that we will be using carbon dioxide scrubbers. Atmospheric composition is crop specific. However, as a general rule, the most common combinations are 2 to 5% oxygen and 3 to 10% carbon dioxide. See, both oxygen and carbon dioxide percentage shouldn't be more than 10%. Oxygen should be between 2 to 5%. Below 2% also it shouldn't go. The storage room atmosphere samples are taken daily for carbon dioxide and oxygen monitoring. Let us see the difference between controlled atmosphere and modified atmosphere storage. Controlled atmosphere has high degree of control over gas concentration, whereas there is no control over gas concentration after it is packed or stored in modified atmosphere. So therefore controlled atmosphere storage has longer storage life when compared to modified storage. When it comes to the cost, this CA storage, controlled atmosphere storage, is expensive because you have to have all the controlling agents and proper testing of the gases in the storage area. Whereas in modified atmospheric storage, once you make the changes in the gaseous composition and moisture and humidity, it is done. Further cross verification is not there. Next is, in controlled atmosphere storage, atmosphere is modified by adding gas, whereas in modified atmosphere storage, it is created by either actively adding or removing gas or passively producing the gas inside the package. Next is, controlled atmosphere storage has specific temperature which has to be maintained. So in modified atmosphere, it may or may not be maintained. Okay, that's the difference between controlled atmosphere and modified atmospheric storage. So that's all about controlled atmosphere and modified atmospheric storage. If you have any queries, you can contact the number on the screen. Thank you. Goodbye. Continue your studies with iiocs.com Food Tech Club.